we will show you our presentation about the history of numbers. So this is what we will see. And this is the first part, the mathematics in the ancient Egypt civilization. I worked in this part with Catherine from Iceland. This is the contents of this part. And an historical point. Egypt is an empire directed by a pharaoh. There is different gods in north and in south. Many of them have relationships, which is different than the Roman and the Grecian gods. They invented pyramids before the pre-Columbian civilizations. Then they invented the script, and it's divided in three main periods: the Old Kingdom, the Middle Kingdom, and the New Kingdom. So this is a poster about of the ancient Egypt civilization. This is the main flow of the Egyptian.
Main river.
The main river, yes. So this is the numbers of the ancient Egypt civilization. They are different that we know now. Maybe one can influence the one of Roman, and there is not zero, who is very difficult for her. The ancient Egypt has different measuring units. For example, for the hours, the day, and the months, this is like hour now. But there is not 5 seasons, but 3. The inundation season, the emergence season, and the harvest season. They're during 4 months, and there is a year from hour. So this is the units of volume and capacity. Like other units, there is a difference than the Middle Kingdom and the New Kingdom. The units of length, they don't exist now, but they have influenced the British units. This is the units of weight. There is not existed anymore, but there is again a difference between the Middle Kingdom and the New Kingdom. This is a problem of equitable distribution and accurate measurement. This is difficult for the division and others. So now Imhotep. Imhotep lived in the 1st millennium before Christ. He is an engineer in the Step Pyramid, like the Pyramid of Djoser, a doctor and an architect for the Pyramid of Saqqara, and de facto a mathematician. He is the first architect of the history, the first vizier of the ancient Egypt, and after a death he became a god. So this is the Step Pyramid of Djoser in Saqqara in Egypt. So she was created by Imhotep in negative 2006. This is a 6 mastaba state in seafloor. It's an inclination of 51 degrees, and this is the first pyramid of the history. So the ancient Egypt has influenced the Grecian mathematicians like Archimedes and Pythagoras. So this is the rest of the ancient Egypt mathematics. The Rhine Papyrus, who is in the British Museum in London. This is the first triangle where there are a theoretic utilization of number, because they haven't the Pythagoras theorem. Some Egyptologists have claimed that the ancient Egyptians used an approximation of P as 22/7 during the Old Kingdom. This approximation was 3.16, and the Grecian mathematician Archimedes found P is equal to 3.14.
When the numbers were invented in India during the century, before Crete, but diffusion during the first part of the 9th century in Baghdad.
Very good.
While 0 and 1 were then first written as real numbers. Natural and integer 0 and 1 play a special role. In ancient times, the Greek considered that the integer started at 2. They definited an integer as a multiplicity. The integer 1 has particular properties. The 0 first appear as an empty place. The system of numeration was accepted as a very like that. When 0 was firstly accepted as a number at y. 0 is a figure and a number. This name is coming of Sanskrit.
Okay. Let's start again. Okay, it's okay. We got it. Okay, this is the question. You can see the question. It's okay. Thank you very much. Just read the first 4 lines. Just read, okay? Just 4 lines. Okay, let's go.
0 is a figure and a number. His name is coming of Sanskrit Sunya, who means empty. Was translated by the Arab in as Sif, then by the Italian in Serifo.
Okay, next question. Only 2 lines each time, okay? Next question.
What was the purpose of accepting the root of -1? The magic number has produced complex number, at least those that are not real, is severely gated. It is equal to the square root of -1.
Okay, very good. So you have many other questions, right? Can you show us the questions? Yes. Yes, can you show us just the question? Okay.
Which number came first, negative or fraction? We cannot measure everything with two fractions. That is why they have been used since antiquity. These are the numbers that have appeared after the integer to deal with giant problems.
Okay, it's okay. Thank you. Now let's back to the presentation because
Which irrational number?
Erika, let's back to the presentation, Matthew, please. It's okay, thank you. It's okay. Do you have something else in your presentation?
Yes.
Yes? It was very good, Erika. Okay, it's okay, but it would be so too long otherwise. So the next part is about...
The set of numbers.
Okay.
So this is the set of numbers. We can see the natural numbers.
Okay. So for example here.
6, 2, and 51.
Okay.
After there is the integer. This is all the numbers. No, this is the numbers more than 0.
Mm-hmm.
This is decimal numbers. This is numbers with additional script, like 3.116.
Mm-hmm.
This is the fraction.
Yes, rational.
The rational numbers. This is the fractional form of z, like 22/7. And this is the real numbers. This is all the numbers, like I don't know, 1 or p.
Okay, pi.
Pi.
Very good. C'est sympa le truc, les images interactives.
So this is our conclusion. This is the part A. The Egyptian civilization is one of the first whose we have a mark of the mathematic domain. This mathematics influenced the Grecian mathematics. The part B.
The number we know are invented by the Indian civilization during the century
Fifth.
before. There were traveled Indians to Baghdad.
Okay.
Natural numbers are naturally numbers you count on your hands and your feet. 1, 2, 3, 4, 5, 6, and so on. Whole numbers are natural numbers plus 0. That's the only difference. Oh, oh. 0, 1, 2, 3, and so on. Integers are whole numbers plus negatives. They look a little bit like this. -2, -1.
Okay, and so on. Okay, so can you make a break? Yes, pause. Okay. Looks like it's okay?
Yes?
Okay, so...
No.
No, it's not okay.
There is a questionnaire.
Okay, just show us the questionnaire, show us the questions. How many questions do you have? Don't ask every question, okay? But just show us the questionnaire.
Now this is divided in 3 parts.
Okay, so we are going to work on it later, okay? Okay, thank you. You can applaud. Yes, very good.